Hey, this is Joe at Great Bench Electronics. Every once in a while I will head over to eBay and look through the vintage electronics section for any interesting listings. And I came across two listings a little while ago for these old PCB boards or PC boards. I believe these are old boards from test equipment from the 60s or 70s. And they are full of, 60s or 70s era components. And I want to be clear, when I found these listings, it was not the test equipment, it was just the boards. It was two boxes of these boards separate. And so I didn't gut out any test equipment that could have been repaired. It was just the boards. Also, some of them are have been cut out of whatever they were before it. Some of them have missing components. But yeah, so it's just a bunch of these boards and they are full of interesting components. Being from the 60s or 70s, the transistors have a much higher likelihood of being germanium, which as a pedal builder, that's always interesting to me. And to that effect, I thought it would be fun to make a video showing salvaging some components out of these PCB boards to make a fuzz face. So that's what we're going to try and do today. The fuzz face obviously is a very simple circuit. We are going to hunt for as many of these components as we can. I'm going to use modern potentiometers, but I should be able to find two germanium transistors of the right spec, hopefully. The resistors here shouldn't be an issue. Hopefully, definitely should be able to find a 10 microfarad output cap. Hopefully also find a 2.2 microfarad input cap, 10 nanofarad output cap, excuse me. And yeah, so I'm gonna get started on that, hunting down some components. We're gonna do it in stages. Because these two resistors here, the 33K collector resistor of Q1 and 8.2K collector resistor of Q2, those values might have to change depending on setting up the correct bias conditions for the two transistors we end up finding. So you want about 0.7 volts on the collector of Q1 and 4.5 or half your supply for Q2. So we're going to hunt down the transistors first. We can also find the 100K, the 30 ohm, and the capacitors, and then we'll build it on a breadboard. We'll put some trim pots for the collectors on the transistors, and then see what resistances we want to actually have for the collectors, and then we'll go search for those resistor values. So if that sounds interesting to you, stick around. Let's get started hunting for some components. Now I should say I did do a bit of homework. I would just look through the boards and found part numbers for the transistors that are at least the part numbers that I can see. A lot of them are house numbers. Some of them have the JEDEC designation 2N and something. Some of them are more the these 1853 dash something house numbers or part numbers 1850. And a couple of them I've pulled out and we're able to test for PNP or NPN, what semiconductor material, or G for germanium, S for silicon. If we can, it'd be nice to make an NPN fuzz face, then the power is consistent with modern effects, but it can be sometimes hard to find NPN germanium transistors that are of the right spec. So we're also going to find some PNP transistors. So we're probably going to pull out a bunch of germanium transistors and see what we can find in terms of spec to make it work for the fuzz face. All right, so here are the parts that are moved from the boards. We got some transistors here. I think I found all NPN germanium transistors, so hopefully we'll have the correct spec parts in this group that we'll be able to make our fuzz face. As far as part numbers here, this is a 2N1304. Here it's a little hard to read, but these are 2N1302s. Those are both NPN germaniums. More 1302s. I think there is, here's a 2N388A. Also have some resistors here. Got 330 ohm, got a couple of 330 ohms there, and 100K feedback resistor, like that. This is a 22 microfarad cap for the bypass, Q2 bypass. Here is a 2.2 microfarad for the input cap, and another 100K resistor for feedback if necessary, and also pulled out one of those 0.01 capacitors for the output cap. So let's test the transistors and see what specs we've got here. All right, so if you're unfamiliar, this is a Peak Atlas DCA Pro. It is a type of transistor tester, and it's a good model to use for germanium transistors because it takes into account leakage when it tests for gain. So I'm going to go through and test each of these germanium transistors. Speaking of testing germanium, you want to be careful. You want to make sure not to touch germanium transistors because even the heat from your fingers can cause the readings, the measurements, to drift high. So you want to make sure to use either gloves on your hand or use tweezers to manipulate the transistors. So I'm going to test all these transistors and write down the values for gain and leakage for each. All right, so we got all the germanium transistors tested. Very happy to find that leakage measurements are all totally acceptable. This leakage number is in microamps. So to find NPN germanium transistors with low leakage, like leakage under 100 microamps, is good. And that probably just is a testament to the quality of the equipment that these boards came out of. Is they were probably selected, these transistors, for high performance. So as far as the readings, not totally ideal. We have some pretty high transistors here. This 158 HFE, 138, 128 is ideal for a Q2. You want something around 120, 116, 111. What we're really missing here is something lower gain. So usually for Q1 on a fuzz face, you want 70 to 90 HFE. So I think what I'm going to do here is we're going to go for, well, two factors. Number one, the Peak DCA Atlas DCA 75, that tests at a pretty high collector current of 5 milliamps. So the 80 to 120 number, Q1 to Q2, that was probably tested at a lower collector current. And so these numbers are probably higher than like a relative measurement would be for other people. That combined with the fact that you can play with your HFE a bit. So I think we're going to go for a higher gain fuzz face, and we're going to use number 9 here and number 4. Number 9 is the part number that I only grabbed one of, which is a 2N388A. And number 4, a 2N1302. So those are going to be our two transistors, at least in terms of specs. We obviously have to listen to the transistor. It might be the case that they have some noise or crackling that we then would have to roll them out, but we can't tell that until much later. So we're now going to build the circuit on a breadboard, and we're going to get these transistors under their working bias conditions to see what the collector resistances need to be, and then we'll go back to the PCBs and pull resistors that are close to that value. All right, so we got the fuzz face built on the breadboard here, and we're going to test for the collector voltage on the two germanium transistors. As a reminder, we have Q1 here, which is 2N388A. That was measuring at 111 HFE and 97 microamps of leakage. And then Q2 over here is a 2N1302, and that was 138 HFE with 48 microamps of leakage. I have two trim pots here, which are serving as collector resistors. This is trim pot for Q2 and trim pot for Q1. Q1 is a 50K trim pot, so anywhere from 0 to 50 kilo ohms or 50,000 ohms. And Q2 is a 10K trim pot. So those are taking place of the 33K and the 8.2K. We're going to dial those in until we see 0.7 volts for the Q2 collector and 4.5 volts for the that was 0.7 volts for Q1 collector and 4.5 volts for the Q2 collector. So I got a multimeter here and set for DC voltage and turn on the breadboard here. By the way, this is the breadboard from Pedal PCB. I'll put a link to this breadboard in the description if you want to grab one of these. Not sponsored or anything, it works well for me. So we're going to check Q1 first. And here is, so there's Q1, and we're measuring pretty close, 0.696, very close actually. Let's see, so if we dial this, all right, 0.698, that's close enough for me. And then we'll come over here to the collector of Q2, right there, and we're at 6.5 volts or so, 6.5 volts. It's a larger potentiometer overall, so the adjustment is less fine. Now we're going to go back to Q1 and check that again. Same thing, 0.698. And back here, 4.6. See if we can dial that in a little bit closer. There we go. 4.5. And then 0.697. So now that we have the transistors dialed in for bias, we can turn off the breadboard, turn off the multimeter, and now we're going to pull out those two trim pots and jot down what the values of the trim pots are set to now. All right, so here is the Q1 trim pot. Q1 trim pot is set to 24.14, and then Q2 is set to 8.26, almost exactly what the fuzz face schematic specified. All right, so we're looking for a 24K and an 8.2K. All right, so now we've assembled all the components necessary to make our fuzz face. I am going to build this on strip board here, or tag board, wherever you want to call it. I got my little tag board made up here. The design that I'm using is for the Diaz Texas Square Fuzz, which is pretty much just a fuzz face clone, a couple different values. It was made by Rocket88, so shout out to Rocket88, thank you for the design. So we have our 22 microfarad bypass cap, 2.2 microfarad input cap, our two transistors that we tested earlier. I'm going to do little sockets for the transistors just in case they go bad or want to try different values. Got our resistors and our output cap, and there's a design there. So let's get started reassembling. Oh yeah, and here's our two potentiometers, just using modern pots because there wasn't really any potentiometers that I wanted to use out of the old PCBs. So let's get started assembling the PCB here. Here is the little fuzz face PCB all assembled now. Got a couple wires attached, ready to go into an enclosure. 2 transistors. It's all pretty packed in there, pretty tight. It's a pretty small, compact little build. I think this would probably fit into a 1590A if we wanted to, but I was going to go for a standard 1590B. So let's move on to assembling the pedal. All right, so here is our Salvage fuzz face all assembled. We've got our 2 transistors in there on sockets. Got our fuzz and volume pots, battery obviously, little LED. The switching scheme I used is this one here from Screddy. And for the LED, we just got a little current limiting resistor coming over here to the LED, and then power's coming up here and just jumping right onto this 330K. I should have had a little forethought and put a wire in for the LED, but something for next time. The battery is wired so that with the input jack not plugged in, or input plug for your guitar not plugged in, the battery is out of circuit, so you won't be draining power. Let's put the back door on. All right, I'm going to employ my specially designed and patented pedal labeling techniques. This is a family secret handed down over many generations. So there it is. Fuzz face pedal out of salvage parts from old vintage PCBs. Suppose there's really only one thing left to do.